All right, okay, there we go. Now we're recording. Perfect. Well, welcome to class today. It's February now, so we're getting into it. So the end of this week is your first exam. I just wanted to remind you of that really quickly. So that will open again on Friday. Basically, as soon as it changes to Friday, it's going to be open, and then it will close Saturday just before midnight. So you have, what is that then? That 48-hour period, yeah, 48 hours that you can pick any time in there that it's convenient for you and your work schedule. If you know right now that you're going to be out of town for that, I could open it early for you. So let me know in advance. So it's better to do that so that you don't lose any points. If you have to take the exam late, like it says in the syllabus, I very rarely do that. Some students, for example, last semester, they got in a car accident the day of the exam. So they were in the hospital over the exam. So I obviously let them take it after. But it's not something like, hey, I forgot to take the exam, then I open it up for you. It's extreme circumstances like that. So let me know if you need it opened early. Otherwise, take it sometime that's convenient for you and your work schedule within that time. Make sure you have good internet connection. So if you know your internet at home is really spotty or cuts out a lot, it might be best to say drive to, I don't know, a coffee shop or a library and access their Wi-Fi. You can usually even do that from, say, your car if you have a laptop. The computer labs on campus are open as well if you would feel comfortable doing that. So there's some options for you. Today we're going to get into chapter 4, and then we will probably finish chapter 4 before the end of lecture Thursday. So at that point, we'll probably move over to discussing the study guide. So as a reminder, you do have a study guide here on Canvas. Feel free to go over, I mean, at the end of today, we'll probably have covered most of what's on that study guide. So get yourself studying, reviewing notes. You can even have meetings with other students here. So if you see there's other students that are participating in class, who seem like they know what they're talking about during lectures or something like that, you can send them a direct message through Canvas or even here through Teams. And then you can even meet here in Teams. So you can have a video chat with, I don't know, a little study group of like 2 to 6 or even more of you, so that you can go over the study guide together on your own time. So that could be a really good use of this space, because this is essentially a classroom area that's just open for you all the time. So at any time, you and a study group could meet here in this main general meeting room, and that would be just fine. You could also meet, I will show you, you could also decide, hey, let's meet in this A through E meeting room. And so basically these are just extra rooms that you could meet in. So feel free to do that if you want. I know study groups can be really helpful. You can go over the study guide, because I don't know that we'll have time to completely cover the study guide in class on Thursday. As a reminder, the exam is 90 minutes. There's 60 questions on it. They're all multiple choice. And open note and open book. That's what I was going to say. All right, so any questions about the exam or logistics or what's coming up in class at all? We might have a discussion activity Thursday. I don't think we'll get to it today. Probably first thing Thursday, though. All right, well, let's jump back into talking about cognitive development in childhood.
Quick question, Brian.
Yeah, go for it.
The material that we will be covering on Thursday, are they going to be on the exam on Friday?
Yep, it will. So the material Thursday is also from chapter 4. The slides are already available to you, so you can go forward in the slides and look over those. But hopefully you've already read the chapter, because your chapter 4 Smart Book is due today. So hopefully you've already read the chapter, covered it once, and then Thursday will be you covering it twice, and then you can go over it again in your study guide.
Okay.
Yeah. All right. Well, let's finish up with chapter 3. We've got just a couple more topics here, and then we will jump into chapter 4 today. Okay, so we stopped off with what do infants see? We did this video of the visual cliff and how very young infants, their depth perception is just starting to be built, but by the time they're about 6 months, they have built that depth perception. because of experiencing the environment. So a lot of things with infant cognitive development come from experiencing things in the world. All right, so hearing. So fetuses in the last couple months in the womb can hear things, and it helps the brain to be able to recognize patterns of human speech. So it's really interesting. They're very attuned to the same kind of pitch, timbre, volume, rhythm that we use when we're speaking. So that time being able to use ears in the womb helps that part of the brain start to specialize, versus the eyes don't really get that chance in the womb to start to specialize and recognize shapes and colors and things like that. So with that being said, a lot of times we like to whisper to infants, but they actually have a harder time hearing those really soft sounds. So it might seem funny to maybe people around you because it's kind of the norm to go and whisper to a baby, oh, you're so cute, that kind of thing. It's actually more helpful for the baby to talk at a normal voice or even slightly louder. So you shouldn't be yelling in their faces, obviously. You don't pick up your niece or nephew and yell at them, hopefully. What you would do, though, talk a little bit louder than normal, and that helps them hear those sounds a lot easier and can help them learn language a little bit faster that way. So at your normal speed, or I mean right now, it might be hard to come across because it's over your speakers or earphones, through my microphone, all those kinds of things. But I'm talking a little bit louder than I just do in day-to-day life right now. Kind of like that volume level. So with that, infants especially, are starting to connect the different parts of their brain together to perceive things together. So hearing a sound and then being able to look at it and see where that sound is coming from, feeling a texture and smelling a smell at the same time, things like that. They're being able to integrate information. That's intermodal perception. So they're developing that ability through experience. So with that, it's still hard at 6 months to connect different senses because those neurons are still making connections between each other. It's still experiencing things enough times that they have the memories of, oh, this and this are connected to each other. Oh, a cat is soft or something like that. So, but by age 1, they're pretty adept. They've had some experiences, especially if they've gotten the chance to play and interact with more things. And at about year 1, that's when they are already able to move around on their own, so they can explore on their own. So that really helps with that cognitive development. So with that, it's really important to help children experience different kinds of speech. Music, rhyming, poetry can be good, touch, smells, all sorts of things. So experiencing things is going to be the best thing for their neural development and their cognitive development. All right, so we'll talk a lot about Piaget in each of these chapters. Well, maybe not a lot. We'll touch on Piaget in each set of cognitive development until about adolescence. So Piaget had a really popular stage theory of development. Piaget came around just a little bit after Freud. So Freud had a stage theory of development that everything was motivated by psychosexual urges that were basically you didn't know what your motivations were. Piaget had a stage theory that said, well, a lot of the capacities that children build are based on their cognitive development, how they process things in their mind. So it was really popular for a long time. He made a lot of good observations about what children were capable of until about the adolescent years. And at that point, similar to other people, Piaget and other psychologists thought, well, after you get to adolescence and through adolescence, you're pretty much done. All your development is done at that point. We don't need to research that anymore. They were wrong. And he was wrong about a lot of the things that he said children were processing. So a lot of this was from observation, not much from experimentation, not a lot of correlational studies, but for the time period, he did a really good job and got us started off on a path of, hey, we can research these aspects of cognitive development. So a lot of Piaget's stuff is not super relevant today, but because it was such a big popular stage theory for so long, it's kind of like held on for a long time. Honestly, I wouldn't be disappointed if I picked up an Intro to Development book or like a first development book and there was no Piaget in it, other than like a mention of him as history. That's what I'm hoping for in the future, because there's a couple pieces that of Piaget's ideas that have continued and are really relevant today. But most of the stages, like the sensory motor stage, while you can memorize that and probably should know what each of these stages are for the exam, in today's psychology, if you're practicing now, doing research, doing therapy, any aspect of psychology, these stages aren't super useful. So we'll touch on them because you'll see some of the things that we've carried on through time in psychology, but the specifics of this are not super relevant today. So basically said that in a different way. So what do cognitive researchers do now? Well, now we don't really have a stage model of development in development at all. So our models are those bioecological models, so where the context, the settings around people affect them throughout time. And there's a lot of plasticity, a lot of things can change at any given time. While there are kind of milestones that we can see people reaching, for example, abstract thinking in early childhood, that is a pretty significant milestone that happens from cognitive and neural development. Another thing with Piaget, they didn't have neuroimaging technology. So it was hard to see what was the brain actually doing. It was kind of just an assumption, this is how memory works, versus now we can kind of see, well, these are the parts of the brain that are talking to each other and describe the process a lot better. So basically, the science has come further from that. So now we investigate specific learning processes. That was a long spiel to basically get here. So we investigate specific things like how do we learn language? How do we process a memory? How do we process visual information? How do we put visual information together with balance? So we look at specific processes that the brain is processing. So that's what cognitive researchers doing now are doing now. There's no overarching stage theory. The overarching developmental theory includes cognitive development under its umbrella. So, and there's a lot more focus on the brain and neuroscience, how the neurons are working, how the parts of the brain are working together. So one of the big things that we look at as one of those topics is attention, especially in infancy. Attention is simply that act of focusing your mental resources. If you're, I don't know, if you're cooking eggs on the stove right now and that's starting to burn or something like that, hopefully your attention goes over there and you can process that and deal with that. Versus if that's not happening, hopefully you're paying attention to the lecture and you can improve your cognitive processing of the lecture, which improves things like memory, all sorts of things. So attention is one of the big foundational pieces of our cognitive abilities. So we understand and we perceive things better when we attend to them. So one thing that infants learn from and build in their cognitive development is imitation. So they practice facial expressions that they see. They try to do things that they see other infants or children or adults doing. And these are very important for learning the actual behaviors. So we might be able to imitate a few days after observing a behavior. So we observe something one day, then 4 days later. So you take your infant to grandma's house and grandma showed them something. And then that day you don't see it, the next day you don't see it, but then the day after that, they start imitating that behavior they saw multiple days ago. It's a capacity humans have. So memory is simply the retention of information over time. And we'll talk about a couple different types of memory and kind of how they work. So implicit memory and explicit memory. Does anybody remember the definitions of those from their reading? What implicit is and what explicit is, and maybe an example of one or both? So you can either type it in the conversation box, which as a reminder is down here. You can click here and see the conversation, or raise your hand with this button.
Hey, Brian, if I remember right, explicit memory is where you're trying to actually learn it. For example, learning this class, reading, immersing yourself in something where you're trying to remember. Implicit is like the unconscious memory, or I didn't mean to, but I remember, some of the things maybe I saw during my day, or um, anything that you didn't deliberately mean to remember, but you still remember.
Yeah, that's a pretty good description of them. I think the idea of unconscious memory for implicit is a good one. Implicit is another example of that, would be something like using a spoon or how to ride a bike. There's something that you don't have to like think, oh, how do I pedal, or like call up an image. You could think of muscle memory as being an implicit memory. So you're not consciously trying to like think back to that thing. So that unconscious memory, that's a good description of it. And yeah, really good for explicit memory. In a class, you're trying to make memories of what's happening now, who is Piaget, what's the bioecological systems theory. Yeah, and so a lot of the things that we think of as memories, usually we're talking about explicit memories. So the facts, the experiences. I took my kids to the ice castles in, what was that, Midway, for their birthday. And so now I have explicit memories of that event, like the glowing ice walls and things like that, them sliding down ice slides. So those are explicit memories. Yeah. So really good examples there. And generally we think of explicit memory when we're talking about memory, but that implicit memory is really important too. So how do you use your phone? How do you use a spoon? How do you ride a bike or drive a car? A lot of those are implicit memories. Some of those, like driving a car, you might be able to remember back to when you were taking, say, a driver's ed course. So some of those explicit memories of learning to drive might be connected to some of those implicit memories, or some things that might have been explicit at one time are now implicit memories. So it's an interesting process. So interestingly, for infants, it doesn't seem, again, remember how we research memory in infants and perception in infants. It's hard because we can't ask an infant who can't speak, hey, do you remember when this happened? And if they're 4 and they're able to speak well enough now, they might not be able to remember that far back. So the research suggests that explicit memory, so remembering the time you went to Disneyland, or remembering when your first birthday or something like that, explicit memory doesn't seem to exist until about 1.5 years old. So what are some neurological changes or neurological reasons why that might be, that we might not have explicit memories until closer to like 1.5 years old? Oh, looks like we've got a comment. Not enough neural connections. Yeah, that's one of the biggest reasons. Very good. Really good answer there. So basically, we are still developing our neural connections up until the age of 2, like we remember. We've got tons of new connections between axons and dendrites. So there's lots of neurons connecting together. But through that process, your brain is also learning how to make a memory. So from day 1, you're not really making the memories yet, or they're not sticking very well. It's not until about 1.5 years old that the brain seems to start to be able to make good explicit memories of events that happened before. Obviously, children can develop these implicit memories, like how to use a spoon or how to stack blocks or things like that. So memory is working, but the ability to, say, recall those memories and call up those explicit memories, because of the lack of neural connections and practice of doing memory, we don't really have any memories until explicit memories until about 1.5 years old, which is pretty neat. This is also one of the reasons that people don't have many memories earlier than, say, 4 is on average around the earliest memory. Some people do have memories as early as, say, like 2.5, but I would be really surprised if anyone in the class has any memories earlier than that. Does anyone think that they have any memories from age like 2 to 3 or even before that they'd be willing to share? And if not, that's totally fine too.
I'll share one really quick.
Yeah, go for it.
When I was almost 2, we did a family trip to the Oregon coast, and I have memories of being on the beach. But I've often thought to myself if those memories are because I've also seen video and pictures of myself there. And so I don't know if it's truly authentic memory or if it's just been like the actual moment has been reaffirmed because of being able to see it externally again.
Yeah, that's actually the exact topic I was going to go into next. Are those really early memories real memories? Because that's the thing, when you're that young, it's definitely possible that you could have a memory of being at the beach that would be something really unusual, probably really dramatic, really different from your day-to-day life. So that would be a situation that's novel enough that you probably would make a memory for it. But with that being said, because neurons are still developing, those connections are still being made, your brain's still figuring out how to make a memory, and keeping it for that long, it does bring up that question. Well, is that a memory, or has it kind of existed or been maintained because you watch those old videos or see old pictures? Or is that now, the memory you have now, is it a complete fabrication based on the stories that you've been told, the pictures and videos you've seen? So it's really difficult to tell, because with that, memories do change over time. And we'll talk, let's get a little more detail into exactly how memories are created, and then we'll talk a little bit more. We'll come back to this memory changing. But yeah, it would be pretty impossible to tell, actually, if that is a real memory or if that is partial real, partial pictures and videos, or all because of the videos that you've seen. So, yep, that's what we were just talking about. Oh, I must have deleted those slides because of time. Well, let's talk about it anyway, because it's an interesting topic. So I think Inside Out is a really interesting way to this. Hopefully you've seen this movie for this example. Otherwise, this example won't make much sense. So Inside Out, it's a Disney Pixar movie about these emotions that are basically driving the brain of this child, Riley, as Riley goes to school, moves to a new house, is having memories. So these yellow ones are like joyful memories, blue ones are like sad memories, and then there's these core memories that make up the personality. So if all of that makes no sense to you, that's totally fine. Probably just ignore this example. But in this, you're making these memories and you're storing them in long-term memory. How does that actually happen? We take a memory, we have an experience going to the Oregon coast, going to Disneyland, learning to drive a car. So we're having this experience, and as we're having that experience, those neurons are active for what we're doing. So right now I'm well, obviously not right now. Right now I'm sitting in a chair in my office. But let's say right now I'm driving a car, and so my arms are a specific way. I'm hearing specific things. I'm seeing things, probably the road and the dash. There might be certain smells in the car. There might be certain people in the car, maybe some friends or acquaintances. So I took a driver's ed class, and one of my friends was in the class with me, and another kid that like we kind of knew a little bit. So my memories of those people are now also connected to this memory, because the neurons that work while I'm learning to drive the car, those smells, those sights, the specific car I was using, it was actually a Dodge Intrepid was what I was using to learn to drive. I don't see many of those on the roads anymore. They must not have been that reliable. So that's my memory of that. And so all those neural connections were working of what I was seeing, what I was hearing, the people that were there. So when I was asleep, or even later on when I think, like right now, when I'm thinking back to that memory, essentially what memory is you've got a section of your brain that essentially says, hey, this is where that memory is stored. So that's in the amygdala. That kind of says, hey, this is where that memory is stored. And so it starts a cycle through those same, not all the same neurons, but a lot of those same neurons that were active at that time. So when you're remembering something, you're in a way really reliving it, because a lot of those same neurons that were active at the time are reactivated through that memory. So let's say there was a specific smell, maybe a specific air freshener in the car. The next time you smell that smell in your life, or maybe like years down the road, you might smell that smell, and it can trigger a memory because of that smell, because that neuron or those set of neurons connected to that memory and connected to that smell are also connected to that memory. That's how also triggers for like trauma can work as well, is because you're actually activating part of the series of neurons that activate like a traumatic memory, for example. But let's focus on just general memories. So when I think of one of those, that friend or that acquaintance, let's go with that acquaintance, because I didn't have many interactions with them. When I think back to that person, I can see them like in the halls at school, but I also see them like in the back seat while I'm driving around in this car. So it activates as I remember something about that person. It can trigger other new memories. So you might be able to follow like your memory train. So similar to how different memories might be connected in Inside Out. Also there in Inside Out, there was that one memory that the like assistants back in long-term storage would send up of the double mint gum. So that was like a really bright glowing ball. It never faded because they kept remembering that silly song. Any memory that you are remembering is those connections between the neurons. And so if you're remembering that same thing often enough, it makes those neurons have strong connections. So the axons and dendrites are literally really ready to activate with each other. So that's why some memories are really strong. Also going back to traumatic memories, that can be one reason traumatic memories are really strong and stick around, because it can lead to a lot of other things like extra stress, maybe fear, things like that. But that's all down to the neural biology of the connections between those neurons. So no single neuron is like your memory for learning to drive a car or going to the beach. It's the set of like occipital lobe neurons that saw things at the beach, as well as things that you heard being processed, things that you felt or smelt being processed. So some of those same exact neurons are activating at any given time. This is also how memories can change. So going back to the Inside Out example, sadness when touching a memory would make that memory turn blue in the movie. A similar thing happens to us. So when we have new experiences that affect that old memory, we can kind of color that memory in a specific way. So let's say that friend that I had that was with me in the car, maybe later on we had a really bad falling out. So we got really mad at each other, or something really sad happened. Whatever the emotion was, that memory that I have of them in the car might be kind of colored by that later experience. So if we had a really sad, maybe something really sad happened to them. So now when I look back and I'm remembering them and the neural circuitry of driving that car, and also helps activate that neural circuitry of that friend, that memory might now be a little bit sad to me, even though before what I remember is like being anxious or something like that. So that can happen after, let's say you're dating someone, then you have a really bad breakup. Your memories of that person from the beginning, so you might have like really happy memories of, say, your first date or something like that. But then after the breakup, you look back at it, and that memory now, rather than remembering the happiness, you might remember sadness. So your memory has now kind of been colored because the neural network has changed a little bit. So that is, at the physical level, really simply, how memories change over time, which is pretty neat. And also one reason that we can change memories of going to the beach when we're 2, they can be changed by the pictures or the videos we see, because now how we imagine, like today, if I tried to remember something at age 4, the way I imagine it might get put in parallel with the actual neural network of memories. So that thing I've changed might now change that memory. So I think it's a pretty neat process, more detail than I intended to go into today, but it is pretty useful to know for how we develop our cognitive development in memory. Yeah, we'll come back to memory at later chapters as well, talk about how other things like emotion affects it in more detail. Any questions about that, though? I know your book didn't go into that much detail, and neither do the slides now. So any questions you have, go for it. And feel free to raise your hand or even type a question at any time, especially if the words I'm using are you're not understanding. I think I did a pretty good job there, not using language that we haven't covered yet. All right, so speaking of language, feel free to keep typing your questions and we can jump right back to that. That's totally fine. So language is communication through written, spoken, or signed symbols. So how do we learn language? Well, basically by experience. So the more experience you have early on with more different kinds of languages, the more likely you will be to be able to keep multiple languages throughout your life. So the sounds that children make, the trying to imitate sounds that other people make, those are the first steps of learning how to speak. So you can see these milestones here. Generally around year 1 or just a little after the first year is when a first word will be spoken, usually something like mama, dada, or cat, or something like that. One of the a psychologist that writes a lot of books on comic books, he says I'm not sure how true this is. This might just be like marketing BS from him, but he says his first words was Batman, which is a pretty complex word, but also some of the first pictures that he's ever drawn, like he's shown pictures of the things he's drawn that his mother kept, they were actually Batman. So maybe it might just be marketing though. Either way, funny connection there. So with that, a baby at this time is hearing a lot of different sounds, hearing how we speak. This is why speaking just a little bit louder, slower, clearer, letting them hear different kinds of voices. So things that are rhyming, things that are lyrical, all sorts of different kinds of voices are best so that they can understand how language works because they experience it, they try out words, things like that. I had a cognitive development teacher who, I might have told this story earlier on in the class. He was French, his wife was Ukrainian, and they were living in the US. So when he was alone with his kids, ever since they were babies, he would speak to them only in French. When she was alone with the kids, she would speak to them only in, I believe it was Russian, even though she speaks Russian and Ukrainian. She spoke to them only in Russian. Then when they were together, both parents were together with the kids, they would speak in English. So these children, they were trilingual automatically. So also, there's a lot of interesting research on, and I think we get into it in childhood development, so maybe I'll wait for that. Being bilingual or trilingual seems to put you a little bit at an advantage for other cognitive tasks like problem solving and math, which is really interesting, and only seems to affect test scores in language, so like English, very early on. So in like kindergarten, first grade, maybe into second grade. But this is just because you might be putting in other words from, let's say you're learning Spanish and English at the same time, you might sometimes be bringing in a Spanish word that's easier for you to remember rather than the English word if you're trying to do English. So, but overall, for actual cognitive development and for processing, you're at an advantage. Just in some scores, you might see a slightly lower score, but you're actually processing things better and faster. So language development. So the neurological developments in our frontal lobe made it possible for us to process language rather than a lot of animal calls. And we're learning more about certain animal calls that seem to be more complex than we used to think, which is pretty interesting. But these are the specific areas of the brain that are really relevant to our processing of language. Oh, that's not what I wanted to do. So mostly in the left area, so left frontal lobe helps produce words. If you get this area damaged, you might be able to understand language, but not be able to speak yourself. So like from a stroke, for example, that's a pretty common thing. And then someone can still understand language and communicate in other ways, but might not be able to create words. And then Wernicke's area is where you're kind of comprehending the language, you're processing a lot of the words, being able to put it together. So this is where a lot of your first and second language would be together, and you'd be kind of mixing it up between the neural connections here in this part of your brain very early on. So Noam Chomsky's studies suggest that humans might be pre-wired to acquire language. So maybe our brains are pre-prepped. So we have the neurological capacity to learn language. So whether that be any language, a lot of the patterns, Chomsky says, between learning languages are the same, are really similar. So we saw these are kind of our milestones, our developmental milestones in all different cultures and contexts, and learning one language or two languages or different, very, well, to adults, very different seeming languages. They're very similar in these kinds of steps. So suggest that neurologically, maybe we're learning them in the same way. All right, so with this, the more words that a child is exposed to in infancy, the better their language is going to be. So reading them books, letting them listen to music, lots of things. With this, we do a lot of child-directed speech. So like I talked about in infancy, we'll often whisper to a child. For a child, we'll often talk in a higher pitch and at a slower tempo with more exaggeration. So, oh, did you find the block? Oh, that's so cool. This is a green block. So I'm emphasizing, I'm talking a little slower, a higher pitch. So many cultures do this, no matter what their languages are, no matter what the culture is. So this might be something that is kind of evolved in us to do. And it does help with learning the language because we're being a little slower, generally a little clearer. With that, when a child is learning a language, helping them when they're saying something. So if they say dog bark, you can correct them and encourage them, show them that they're doing it right by saying, oh, did you hear the dog barking? So this really helps them figure out how we do sentence structure, how the grammar works, and lets them see that, oh, we're listening and they're saying it the right way. Essentially, it lets them know and get reinforced that they're communicating. So with that, oftentimes we do these things naturally, which is really great. If not, though, make a focus to do it. So some of the biggest points of language development is being an active conversational partner. It can be hard with, say, a 2-year-old who their words are kind of slurred. It's hard for you to understand what they're saying. They're using 1 or 2 or 3 word sentences. So it can be hard, but trying to be an active partner and conversing with them, giving them exposure to a lot of language, slowing down. If you have to talk to them in that child-directed speech around other people, don't be embarrassed. Just do that. That's better for the child. Use a lot of gestures, playing games, showing them how language works around the world is really the best thing. So. All right, and that is the end of chapter 3. We'll jump into chapter 4, but before that, let's take a quick break. Are there any questions on these aspects of cognitive development before we jump into socio-emotional development in infancy? All right, well, let's take a quick break and be back at, by my clock, I'm looking at 9:15 then. All right, see you in a moment. All right, and we are back. So, a student during the break said that their internet was going bad right now. Yep, I will put this recording up on Canvas later today, probably just after my next class, so it should be up just at around noon. If you don't see it up by about 2 p.m. this afternoon, please do send me an email, because probably just I forgot to change a setting so that you can see it after I upload it. I've been known to do that sometimes. So let's jump into chapter 4. So the book kind of separates things by age ranges. So we went through in one of our first classes and talked about the phases of life. So we're talking about infancy right now, and it breaks up our physical and cognitive development into one chapter, and then usually socio-emotional development into the next chapter after that. So let's talk about socio-emotional development in infancy. All right, so here we're going to be talking about these topics. We're going to have an activity on attachment that we probably won't get to today. That'll probably be one of the first things we do on Thursday, because that's near the end of the chapter. But a lot of really relevant aspects of social and emotional development early on in infancy affect the life throughout life, and we'll talk about that. So here we have the example again of Inside Out and these emotions. So emotions are the feelings or the affect that we have that occur when a person is in a state or interaction that's important to their self and well-being. So things like anger, if you're feeling threatened or feel like taken advantage of, you might feel anger. If there's something that's important, and it's hard to describe emotions at a really basic level, because there's something that usually we've all experienced, but there's actually a lot of research on each of the emotions, on what exactly are the processes, the cognitive processes and neurological processes that lead to, say, anger or happiness and things like that. So, but here are some examples of positive emotions: joy, love, enthusiasm. Things we consider negative emotions, or like on a negative valence, kind of a negative direction, are anxiety, anger, guilt, or sadness. Now, that being said, it doesn't mean that guilt, for example, is a bad thing. So guilt is actually a moral emotion. So one of my big areas of research is moral development. Guilt, it's actually a motivating emotion that leads people to want to fix whatever is causing them guilt. So if you said something really rude to your sibling or partner, and now you feel guilty for that, that is kind of a negative valence. Like, it doesn't feel good, but it motivates you. It can help motivate you to do something good, to repair that relationship. So moral emotions generally do motivate you to do something. So empathy is another example that's more on the positive valence end, where you might feel empathy for someone, and so you're sharing their thoughts and their feelings, and it will generally motivate you to do things for them, or like for their benefit. So another example of emotion. So emotions can do a lot of different things. They're really important in our communication. So as an example, and this is maybe a mean one. So my daughter the other day, I forget what she was doing. I think she was just reading in her room, but she wouldn't listen to me saying anything. So I was like, well, you know, if I use like an angry voice, even though I wasn't mad at her, she might start to pay attention. So I used an angry voice. So I was communicating in a way that to her said, oh, Dad's angry. But I was like, you did such a good job on your spelling test. And she was a little confused for a second, but then she smiled and she realized that, well, I wasn't actually angry at her. So it was an example of confusing that. Like, usually our emotions are important in communication in specific ways. Obviously for her, I used it because it tried to get her attention, an angry kind of voice, to tell her something positive. So with that, so behaviors and social responses in interacting with other people, oftentimes we need to use emotions, and we need to pick up on emotions and interpret them, or even regulate emotions. So in infancy, how does that process start? What emotions appear first? How do we learn to regulate them? That's the kind of thing that we're going to talk about right now. So infants learn about what behaviors are adaptive in their environment through social responses driven by emotion. So they will learn that, say, when I'm hungry, crying and being really upset will get me food. And they'll be reinforced with that. They'll find that that's adaptive. They can find that things that are maybe maladaptive are adaptive to them, and then keep that habit for a while, or they can find that positive things are adaptive to them. So for example, if they do a smile, they might get a smile back, or they might get encouragement, or they might get a tickle or something like that. So they might learn that's adaptive and do that more often because they're reinforced. So joy, sadness, interest, and fear are all emotions that infants can feel, some of the most early emotions. Going back to empathy, because it's one that's the most interesting to me. Infants can actually feel what other people are feeling, but empathy is two parts. So you've got that ability to feel what others are feeling. So feel the sadness if they're feeling sad, feel happy if they're feeling happy, that kind of thing. But empathy also has that cognitive piece of taking another's perspective, putting yourself in their shoes. Infants aren't capable of that part yet. But infants have the startings of empathy in being able to feel what others feel. They do this really well with other infants. So if you put two infants together in a room and one starts getting sad and crying in a sad way, the other one will start crying in a sad way and start getting sad. They'll start to share that emotion. Those are some of the initial seeds of the development of empathy. All right, but it's not the full empathy until in childhood later on. So the brainstem, hippocampus, and amygdala all play a role in emotions. So we often talk about the amygdala as being like a center for emotions because a lot of the emotions are kind of going through there. That's part of the neural network for almost all emotions, but also the brainstem getting information from our body, from our sensations and perceptions, as well as hippocampus are all important. So the regulation of emotions comes through the development of the prefrontal cortex. So this is one reason that it's harder for adolescents, especially going through puberty, to regulate emotions than it is for adults. I mean, this is a multi-part thing that we'll talk about later on. Adolescents are feeling emotions because their amygdala, their hippocampus, that is all myelinating at the time you're about 13, 14. So you might notice that a teen is a little more moody because basically their emotion signals in their neurons are stronger, faster. So they are literally feeling emotions stronger, more dramatically, a wider range of emotions than they ever have in their life. But the prefrontal cortex isn't finished myelinating. So those emotion signals are really fast, really strong, but they don't have the neural capacity yet, as an adult would, who's say 28 or so, to regulate those as well. Like specific training, you can get better with it. Practice, you can get better with it, obviously. But that's one of the reasons that adolescents seem to be so moody, and we'll talk about that as we get to adolescence as well. Yep, that's what I was just saying. I just clicked this the other day, and I think that funny story about Stock University is gone now, which is sad. I'm trying to find it again, though, because it was funny. All right, so as the frontal lobe and prefrontal cortex develop, children can learn new cognitive strategies to control their emotions. So you don't have to wait until your brain is fully myelinated until adulthood to regulate emotion. You can learn from an early age to start regulating emotions, whether it's joy, sadness, anger. You can practice those skills and make the neural connections to be able to regulate emotions better. And so practice does help. For very young infants, the thing that helps best, especially because usually we're trying to get them to regulate more negative valenced emotions, so like anger or frustration or just being mad or scared, one of the best things for their emotion regulation is to hold them. Essentially, to like comfort them, to pick them up and tell them everything is going to be okay. They might not understand the language, but especially being close to your body, it releases specific chemicals in their body, specific hormones that actually help to teach the brain, hey, when I get really upset, when I get really scared, when I get really angry, when I'm upset, I should. So it's essentially training their brain that, hey, when I feel this way, I should start to release these hormones that then calm them down. So it's one of those really important socio-emotional factors that the social interaction between usually a caregiver and that child, the caregiver hopefully is able to regulate their emotions, is able to teach that child how to regulate their emotions because of the child's own natural body processes. So that cuddling behavior will release specific hormones that help make that neural connection. Hey, when I'm feeling this upset, I should start releasing these hormones or start doing something to release these hormones, which will help them to learn their own soothing behavior to release those hormones. So with that, distraction can also work well. Let's say you're in a store and a child is really upset that they can't have, I don't know, whatever they want. Maybe they want to eat a cat and they can't do that or something. Infants and kids want weird things sometimes. So distracting can help a lot. It can basically start a new neural network going. So if they're angry and they're upset and that's all that's running through, all of their thoughts and cognitions are also going through that set of neural network of I'm upset, basically. So distracting. So, hey, look at this really funny thing. Oh, look, I have a bird on my head. Something like that. Distracting them can really help to start a new set of neural networks active. And that can help and distract away from a negative experience, distract towards something positive. That can really help. That can help in adulthood as well. But these are some of the steps to try and teach infants' brains how to do this. So with that, the attachment to parent or attachment to caregiver, usually when we're talking about attachment to parent, we're talking about, most of the research is attachment to mothers. Although these attachment findings, sorry, my cat is trying to destroy something in my room. These attachment findings also apply to fathers that are the primary caregiver, a babysitter if they're actually the primary caregiver, a grandparent or aunt. So whoever the person is that's a primary caregiver, it seems to apply, all this attachment research applies that way too. So with that, happy positive interactions with an infant, so trying to help them have those positive interactions, trying to help them be happy, help lead to those positive emotions being reinforced. Cat, psst, stop. Sorry, it's biting at cords. Likes to do that. So with that, children become better able to manage their own emotions through that sensitive caregiving. So distracting, cuddling helps show the child a healthy way to then regulate their emotions. It's basically training their brain to, when I'm feeling X, go through process A, B, or C to start now feeling D. That's a lot of letters. Maybe that was confusing. Here's a really good article by Darcia Narvaez, which is a good example of a researcher who writes basically blog posts based on the research that she's done. So she's kind of like one of the top names in child moral development and socio-emotional development. So a good example of someone who, while you can find the actual research article if you had, say, a question paper, she herself actually writes these, or maybe some of her grad students do too, I'm not sure, writes it out in plainer language for people as well. So this could be a good example of a good web source for a question paper. So keep that in your mind as well for finding good sources for question papers. But with that, children become better able to manage their emotions through sensitive caregiving. So this article and the research suggest that crying it out is a really bad method to teach them how to regulate their emotions. Essentially, what crying out does is makes that behavior of crying extinct. So the child realizes, hey, I'm not getting the thing I need from crying, I'll just stop crying. But when you look at their neurological, what's happening still, they're still stressed out, even if they're not crying. but they haven't learned how to regulate that emotion. So even if they're quiet, they're just quiet because they know it's not going to get them any kind of attention. So their brain is still stressed out. They still have those stress hormones. Just because they're quiet doesn't mean that they're actually okay. The best thing to do, which can be really frustrating, especially with trying to develop sleep schedules, is to be really attentive, be really responsive, cuddling to help them know, hey, when you're feeling freaked out, these are the kind of hormones that should start to activate. And that is the best thing for helping them. It can be really hard for parents. I know I went through this with just 2 kids. Some people have many kids who have a hard time sleeping. So, but yeah, definitely read that source, look into the actual research on it, and if that's something that you'd be interested in doing for a question paper. So, social relationships help in so many things. Most of the social relationships in infancy are with the primary caregiver, but there might also be some with like peers and a lot more often like secondary caregivers, maybe siblings as well. And with these, the variety of settings that we experience as infants, similar to experiencing a lot of sounds, a lot of different language, a lot of different smells and sights, experiencing a wide variety of emotional and social experiences really helps a child's socio-emotional development. Now, I'm not saying we should like purposely set up elaborate experiments to make a child like feel bad and then help them feel better, but just normal, natural relationship experiences are going to be a really important thing to help a child develop. So it reminds me of this video from Inside Out. Oh no, I didn't check that one because I'm like, that one's going to definitely be there, but no, it's not because Disney was like, no, you can't use my video. Knew I should have checked it. Oh well. So in the movie, Joy tries to stop Sadness from interacting with Riley's like interface, like the big computer desk thing, and all the buttons. Joy tries to put Sadness in a little circle. Say, I'll keep all the sadness in the circle. Don't mess up my kid, essentially is what Joy is trying to say. And later on through the movie, spoiler alert, what they learn is that feeling these emotions have different effects on Riley, and that they're important parts of her life, essentially. So with that being said, as Joy is trying to stop sadness, later learns that sadness is important. That's essentially the same for kids. Yeah, we want to be able to respond. Let's say they're trying to learn to walk and they fall down, they're sad. Well, we shouldn't stop them from trying to walk and failing just because they might get sad. Having that experience of sadness or having a toy taken away, we want to be able to go then and comfort them. But to try and stop any of that from ever happening would be a disservice to their socio-emotional development. So being able to learn through those maybe slightly more negatively valenced experiences as well as the positively valenced experiences. We don't want to avoid sadness or anger or fear. We want to be able to teach a child how to work through those things rather than avoiding them entirely. So surprise, joy, sadness, anger, fear discussed. Those seem to be innate there in the first 6 months of life. Within the first 2 years, we start to see jealousy. We start to see more empathy. In infancy, infants can share emotions with other infants, but they don't yet do it with other children or adults. As they get a little older, they can also share the emotions of, say, older adults. So it starts off with like kids their own age and kind of expands where they're sharing those emotions. Embarrassment, pride, shame, guilt, all develop really quickly. So having experiences that teach them those things and let them experience those emotions are really important. So self-conscious emotions require self-awareness. So a sense of me or I am a separate person, I'm an individual person. And for really young infants, it's not really clear if they have a sense of them as being separate from their primary caregiver, usually the mother. It seems that they don't have that sense of themselves as an individual. So they need to be able to recognize themselves as an other, to be able to separate them and say, hey, I feel this specific way, and that might not happen until age 1. So that's why some of these things like jealousy, pride, embarrassment, having a sense of yourself as a separate person is essential to feeling those emotions. So let's actually watch this video on the development of empathy. I've talked about a lot of these points, so hopefully this isn't just redundant as we go and watch this video. But it's a really good example of some of the socio-emotional development that happens in infancy.
You know when you're reading a really good book and something intense happens to one of your favorite characters, so you are also hit with like a wave of feelings? You might feel a little silly as you reach for a box of tissues, but it's a normal human thing to understand and relate to other people's feelings, even fictional people. We call this empathy. Empathy might seem pretty straightforward, but we know from research that it involves a complex network of brain areas that process things like emotion, thought, and understanding social cues. Many of these brain regions aren't fully developed until late adolescence or early adulthood, so it takes a while for little kids to get it right. To understand the different pieces of the empathy puzzle, scientists often divide it into 3 components: emotional, motivational, and cognitive. And to figure out how and when empathy develops naturally, researchers study how kids behave in different situations. The emotional part refers to sharing someone else's feelings. For example, researchers have tested this by monitoring brain activity as adults watch someone else's hand getting poked with a needle. And you're like your brain does things. And the brains of people watching typically show a similar response pattern to the person actually being poked. This suggests that we actually feel something similar when we see someone in pain. And it seems like this kind of empathy may develop pretty quickly. We think babies as young as 6 to 8 months show early signs of it when they make sounds or facial expressions that mirror others who are upset. Next up is the motivational component, which is basically...
And more recent research does suggest that this actually exists immediately after birth too, which is pretty neat.
the urge to do something for someone else's well-being, like wanting to comfort a friend when they've lost a pet or family member. And even though children might mirror each other's emotions early on, it takes a few years for this motivational part to kick in. When they're about 3 to 6 years old, kids might show behaviors like sharing their favorite stuffed animal to make someone else feel better when they seem sad. Now, the third and maybe most complicated part of empathy is the cognitive component. In the research world, this is sometimes called theory of mind. It's the ability to take another person's perspective, think about their experience, and understand why it would make them feel the way they do. This requires some mental gymnastics, so it's not a huge surprise that it seems to be the hardest part of empathy for young children to do well, and it's easy to mistake for selfishness or meanness. One of the most well-known ways to study theory of mind is called a false belief task. Like there's the Sally Ann task, which involves a short scenario that gets played out with dolls. It goes like this. Sally has a basket, and her friend Anne has a box. Sally puts a marble in her basket and then leaves to go for a walk. While Sally is gone, Anne takes the marble from the basket and puts it into her own box. Jerk move, Anne. After all this, researchers ask children where Sally will look for the marble when she gets back. Kids under 3 years of age will usually say that Sally will look in Anne's box because they saw the marble move, which sounds a little weird to our adult brains. From other questions, researchers can tell that kids are following the logic of the story and understand that Sally didn't see the marble move. But it seems like they have trouble understanding or expressing the fact that Sally's perspective is different from their own. Some researchers think that even if young kids might get that people have different feelings or perspectives, they can't describe it with their cognitive and language abilities. Because the brain systems involved in these abilities become more efficient as connections between neurons develop and change, by age 4 to 5, answers start to change. Basically, their brains are more able to process complex information, so more kids say that Sally would look in her own basket for the marble because that's where she left it. Now, the jury's still out on exactly how and when full-blown empathy develops, but your first few years of life involve a lot of learning about feelings and thoughts. Talking with kids about their emotions, suggesting ways they could show empathy, or even reading stories about feelings can help them figure this stuff out. And then, when they get a little older, you can just give them a good book and also maybe a box of tissues. Also, if you happen to know any little kids and want to share a love of science with them, you can check out our SciShow Kids channel.
So some of those things I covered already. So hopefully you're understanding it a little more. And there's a couple points in there that I haven't made yet. But that it gives you a good sense of how that one emotion develops. And empathy, granted, is one of the more complicated emotions because it does have that cognitive component to be able to put yourself in someone's shoes, share their perspective kind of thing. So that is more complex for empathy versus some emotions are a lot more simple in their neurological capacity. It's essentially we're threatened and we feel a feeling. So some of those are a lot easier than empathy. But hopefully it gives you a sense of how many systems have to work together for full-blown empathy to exist. So it seems like before the age of about 6, full-blown empathy isn't all the way there. So you don't have both the cognitive component with the emotional component. So, and you're kind of early on in infancy, you're developing that emotional component. Then around maybe age 3, you have that emotional component figured out. And then you're starting to figure out that cognitive component. So hopefully that helps you see all these systems that are interacting. The suggestions at the end were really good as well of how to teach and encourage empathy in early childhood. And we can even use similar things to teach and encourage empathy in adolescents or adults who might be struggling with that as well. Yeah. So empathy is one example of a moral emotion. We talked about guilt. So moral emotions basically motivate you in some way to do something for others. So empathy is a really good example. Guilt is. I used to have an example question paper about moral emotions, but I think I removed that from the class just because having 2 was confusing for students. So I just have the one on Ritalin that we already talked about. Yeah. So emotional expression and social relationships. If you've ever interacted with an infant, you will know, especially if it's your own infant and you're around them a lot, they have different cries. So there's a basic cry, an anger cry, and a pain cry. And actually across communities, countries, cultures. That's the C word I was looking for, cultures. It's really interesting that the basic anger and pain cry all share some similarities. So basic cry, it's hard to mimic. I should probably just get an audio file for each of these to play for class. Why didn't I ever think of that before right now? Well, I guess I'll have that for the next time I teach this class. I'll get an audio file to share with students. I don't know, maybe that would be uncomfortable. Let's get a vote really quick. Who would, in describing these, who would actually want to hear one of these cries, or would it just make you kind of sad to hear babies cry during the middle of class? I guess if you don't care either way, maybe don't comment, but if you want to hear it versus not want to hear it, like if it would make you uncomfortable, let me know, or if you think that would be really useful, let me know. So we've got one comment of wanting to, think it'd be a good idea. Okay. Yeah, as long as it was a short clip. Yeah. Okay, perfect. I will find those. I won't find them live right now with us, but I'll put it into the slides and then I'll re-upload the new set of slides. So. All right. Yeah, you have kids, you can tell the difference. Yeah, it's useful for people who aren't around babies often. Yep, for sure. So maybe I'll just come back to this after I've put those in. But there are some definite differences between these kinds of cries. And it's really interesting that across cultures, it's pretty similar, those differences. So with that, let's jump to smiling, because we do have some examples here. So a reflective smile is a smile that doesn't occur in response to any kind of external stimuli. It's just the child happens to smile, essentially. And so a lot of the time in really young infants, what you're seeing generally is a reflective or a reflexive smile. They're not actually smiling in response to something you do. It just happens to be what their face does. But it still is encouraging for the adults or whoever's interacting with the child, and then they interact with them more. So it is adaptive for the child, but generally it's not a social smile until a little bit later on. So social smile is in response to external stimuli. So when you smile and the infant smiles back, that doesn't happen until a couple months after birth. Before that, it's generally a reflexive smile. As for fear, generally, children have a stranger anxiety, a fear or wariness of strangers around 6 months of age is when this can appear. Now, not every child will have that kind of stranger anxiety, but on average, this is about when it appears. And also, this is about when you might notice they will have some kind of distressed crying or like reaching out or be upset when their caregiver leaves. So if you leave them with a babysitter at 4 months, might not seem to care, versus at 7 months, they might now protest and be really upset, even though it's that same babysitter at that same time. So with that, over that first year, infants are developing the ability to inhibit or minimize the intensity of any of their emotions. So it's really important to help teach them that. Things like thumb sucking is an example of something that can be self-soothing. Talking to themselves around 20 months, so once they're developed the ability to talk, they might babble to themselves or talk to themselves. That's an example of coping behavior. Very early on, though, infants do depend on the caregiver's responsiveness to reduce that arousal. The same thing I was talking about earlier on, like a caregiver picking up a child, trying to soothe them, smiling at them, helps their brains to release certain hormones that decrease the cortisol level in their bodies. And as that happens, the brain is learning, hey, this is what I need to do to decrease this emotional intensity or decrease the duration of this negative emotion I'm feeling. So it essentially is helping them learn how to control emotions themselves. All right. Oh, I was thinking, oh no, we're almost done with class for the day. Only have a couple minutes. So context also matter in the development of emotions. So fatigue, hunger, nap time, that is all really relevant to how the emotions are displayed. So I have this example here, this hunger grump example. Both my children, when they get hungry, they tend to get really grumpy, have more negative emotions, not be able to regulate their emotions as well. So sometimes I have to sit and ask myself, hey, is my child being rude, or are they being grumpy? Are they fighting with each other because they're actually mad at each other for something? Or is it because they're both hungry? So looking at those contexts and helping children understand those contexts is important. Hasn't been very successful here, telling them, hey, you're going to get grumpy soon. If you don't eat a snack, please go eat a snack. That seems to fail a lot here. Maybe I need a new technique. Maybe I just need to stuff a granola bar in their mouth or something before they start getting grumpy. Also being tired or overtired can do that. So skipping a nap time. So with that, the context of a mother with depression, so let's say postpartum depression or just clinical depression in general, is a context that affects the socio-emotional development of a child. So we talked about how like the soothing behavior, being really responsive to a child, is really important for them learning to regulate their emotions. Well, one of the symptoms of depression is lower motivation to do things. So mothers with depression do, and this also includes fathers with depression, but usually when we're talking about research with infants, most of the research is on mothers. Is that sexist? A little bit. But with that being said, the caregiver who has depression will tend to rock and soothe the baby less, will not do as many behaviors to help the child regulate their emotions, and that leads to less effective coping strategies for the infant as they're starting to learn those emotion regulation processes. So that's another important context. So that actually puts the child at higher risk of depression in the future. So, and that's partially based on the early experience. That's also partially based on the genetic factors that might make it more likely for that child to suffer from depression in the future too. So that's another important reason to get treatment for that as well. Or just being aware of that can help you do the soothing behaviors more immediately, even if you have that lower motivation to. Maybe knowing this might make it more likely. So next time we will start with temperament. This is kind of like infant personality style, or one way to describe infant personality. So we'll do that, talk about that next time. Thanks for coming to class today. We'll finish chapter 4 next time. Okay, have a good day.